Okay, so hello everyone. I hope that you can hear me. I'd like to welcome you to freemathhelp.ca, and if you're new to the live streams, I'd like to thank you for joining us, or even if you're not new to the live streams. Basically, what we are focusing on with these live streams is really just getting you guys as much math help as humanly possible. So without further ado, we're going to just get started. Basically, the way this works is that if you do have math questions, you are more than welcome to put them into the chat for us to answer them and discuss them and show you a step-by-step example on how to solve that. Now I'm just going to get this working here real quick. Perfect. Okay, so hopefully everybody can see that. And if you can, please just leave me a chat. If you cannot see anything, if you don't see the Cartesian plane and the thing that says grade 9 right now, just please feel free to leave me a message in the chat and I will try to fix that. Okay, so we're going to get started today, and like I said, basically the way that this works is that we like to do a lesson every week, and we also are able to answer your questions. So if you have questions, they can be about the lesson that I'm teaching, but they don't have to be about the lesson that I'm teaching. So if you have questions from your math, it can be about anything. Okay, hi Sarp. So we're going to get started, okay? So again, because everybody across Ontario has a different teacher basically, and everybody has a different setup in terms of what they are doing in the order that they're teaching it, we're basically going to teach all of the main skills that you're really going to need throughout the rest of grade 9 and then going into grade 10 math as well. So again, today's lesson might not be about what you're learning in class right now, or I say in class, but through distance learning, but that doesn't mean that you're not going to need these skills. That said, if you have a question, feel free to send it in. Okay, so today we're going to be talking about linear systems. So the past couple of weeks we've worked on exponent laws, we've worked on polynomials, and all of those skills that we were working on in the previous weeks actually come in handy during this lesson and during this unit, because you really need to understand each of those skills in order to apply them to what we're doing here. So when I say that we're learning about linear systems, what I'm really meaning is that we are actually going to be learning about straight lines. So you see here I have a Cartesian plane, and what we're going to learn today is what constitutes a straight line in terms of the math behind it and how we know something is a straight line. So in order to do that, I'm just going to change the color of my pen here. Basically, in the beginning of this unit, you're always going to be given these little t-tables. And with this t-table, you actually are going to be asked whether or not this is a linear function. So when I say linear, I'm literally just referring to a straight line, okay? That's what a linear function is. And there is a particular way that you can tell whether something is a linear function, and what that is called first differences. So there's a very simple method that you can use in order to determine whether something is a straight line or not. And that really comes down to taking a look at its y values. So what we're going to do here is say, okay, well, what's 70 minus 50? Well, that's going to be 20. And what is 90 minus 70? Also 20. And what is 110 minus 90? That's also 20. And then last but not least, we've got 130 minus 110, which is also 20. So because these first differences are all the same, they're each 20, that means that we are going to have a straight line. Whenever you do the first differences and it's not equal on each difference, that means that the line is not going to be straight. The reason for this is because we need to know that the slope is consistent. So we're going to talk a little bit about what is a slope. So when we look at a straight line like this one here, like this guy in the purple right above, and we want to determine its slope, what we're really asking is, what is the rise over the run? And for you guys who have probably done this unit already, this might be a little bit of a review, but it's important to go over these core skills before we go on to the more complicated stuff so that people who haven't done this unit yet know what I'm talking about, okay? And if you do have questions, like I said, if you're just joining us right now and you have questions that you'd like me to address that don't have anything to do with this, that's totally fine. All you have to do is just submit them in the chat and I will answer them for you, no problem, okay? So when we're talking about the rise over the run, what we're really asking ourselves is, how much is this particular line going up? How many units is it going up? So this is its rise. And how many units is it moving over? And this is its run. And there's a very particular way to determine this, but what we're going to do as well is kind of just go over straight lines in general, and then we're going to talk about the slope formula, okay? So there are three major methods that we use to describe, and I say describe in quotes, but to kind of indicate what a line is going to look like, okay? So as many of you who have taken this unit before might be familiar with, we have the y equals mx plus b method. And then we also have the standard form, which is the ax plus bx plus c equals 0. Oh, sorry, plus by, my bad, equals 0. So this is our slope-intercept form. Whoa. Let's just erase that. Okay, so this is our slope-intercept form. And this is standard form. And sometimes you're going to get teachers who give you the equation of a line in standard form and ask you to put it into slope-intercept form. Okay, so there's many different aspects to this unit. We're going to try to learn the basics first and then move on to the more complicated stuff. But like I said, if you have questions, feel free to submit them in the chat, okay? So typically what we mean by a linear function is something where the rise and the run are consistent over time. So that's why it's a straight line, because you are moving over and up by the same amount each time, okay? So if anyone has any questions about that, just let me know. And we have a couple of different things that are super important to keep in mind. So let's take a look and let me do something like this. Actually, let me use a straight line drawing tool. So let's say we're doing this, and I've got that. Okay, so taking a look at this straight line here, we know that it's a straight line, obviously, so we know that it is a linear function. But what's really important to remember is that when we are looking at this, there are a couple key things that we really need to be concerned about, okay? So what I'm going to do is just make some space over here. So when we're talking about the different aspects of a linear function, what we really need to be aware of are a few key things. So in the slope-intercept form, which is our y equals mx plus b, I'm going to write that again just to make it a little bit easier. We've got some key factors. We have the y, mx plus b. So, let me just turn off the sound on my phone here. Sorry about that, guys. So, what we really are concerned about in particular is the slope and the y-intercept. So this letter tells us the slope, and this letter tells us the y-intercept. So now looking at our graph over here, let's pick a nice color that can show up. You know, we'll just stick with red. Take this nicer red. So when we talk about a y-intercept, what we're asking is where does the line cross the y-axis? So this right here is our y-axis, this line, as many of you guys know. And what we're asking is what is the exact point that the line crosses the y-axis? So in this case, it is right here at 3. So now, keeping that in mind, we can add that over here. So we know that the b term is positive 3 in this particular case. Now, the y and the x don't basically matter in terms of when we're solving for this equation, other than if we were to actually plug in a point, okay? But what we want to do is figure out how many we're moving up and how many we're moving over each time, right? So in this case, we can go ahead and use a very particular formula, okay? So I'm going to teach you guys the formula for solving slope, and I know for some of you who are new to this might be a lot of information all at once, which is why I do recommend, if you want me to slow down or if you want me to explain something a little bit further, please leave a comment in the chat so that we can address any questions you guys have. Because I know that this might be new for some of you guys, but I also don't want to take too long going over each little thing in case everybody has done this already, okay? So what we're going to do is we're going to use a very particular slope formula, okay? And I'm a big fan of using the slope formula and just sticking to using the slope formula whenever you can, because it's the most accurate. Okay. So we know that the letter for slope is m, just as we see right here. And to solve for m, you're going to pick 2 points on the line, and you're going to use this formula, y2 minus y1 over x2 minus x1. Okay? So don't worry, we're going to explain what the heck all of this means, because I know that that can be a little bit confusing. So first step, step 1. Pick 2 points. Simple as that. So pick 2 points on the line. Okay, so I'm going to pick points that are very obviously on the corners so that I can use those very easily. And I'm going to try to stick to using 2 positive points for this example. So in this case, this line, this one right here, this is 2 and 5. So the reason that it's 2, 5 is because this is x and this is y, just like always, just like you guys learned in elementary school. And then this point is 3, 6. Okay, great. So now we've picked our 2 points. What I'm going to do is, again, make some space so that we can make things a little bit more clear for you guys. And what's really important is once you've picked your 2 points, you're going to, and I'm actually just going to move this. Oh, there we go. What we're going to do is actually plug them into this formula. But before we do that, we want to make sure that we have everything figured out. So we've got y2 minus y1 over x2 minus x1. Now, what's really important for you guys to do is actually just write this down. This is where a lot of people lose marks, and I've tutored many, many, many students in grade 9 who lose marks because they don't actually write down what they've chosen as x1 and x2. So above the points, write them out, and you're literally going to write x1, y1, x2, y2, and then refer to these letters every time you're plugging something in. So if we're looking at y2, we've got the number 6, and then that's going to be subtracted, we're going to subtract the number 5 because that's y1. So I'm hoping this is making sense for everybody. And then we've got x2, which is going to be 3, and we're going to subtract the number 2 because that's x1. Okay? So if anyone is confused by that, please let me know. But Remember that we're solving for slope, okay? Great, so 6 minus 5 is 1, 3 minus 2 is 1, so the slope here is 1 divided by 1, meaning that it goes up by 1. So every time we move up by 1, and we're moving over by 1. That's all they're asking. But we can write this as just the number 1 in our equation. Okay, great. So now we're going to double check that what we chose as our equation, or what we solved as our equation, is correct. And this is a really important skill for the rest of all of math, is making sure that you're plugging everything in and checking that it's actually right. So what we're going to do here is we're basically just going to pick any point on the line. So I'm going to pick, let's say, -3, which is our x-intercept because it's on the x-axis. So this point here is -3, 0. And what we're going to do is plug in that point, the x part of that point, into our equation to see if we get the correct answer for y. And this is a very easy way to make sure that your test marks are, the answers on your tests are correct, okay? So I'm going to go 1. I'm going to plug in -3 as x, and then put in the rest of the equation. And lo and behold, 1 times -3 is -3, plus 3, that's going to equal 0, which is the correct answer for y, because our actual point on the graph is -3, 0. Okay? So hopefully this makes a little bit of sense for you guys. We are going to do some other examples, and we're going to do some more practice problems so that everybody can understand this a little bit better. But these are the very key concepts involved in this unit. Understanding y equals mx plus b, what each letter means, be very clear and make sure you're practicing enough that you know what each letter actually equals. And then that way you can actually have a good understanding of what you need to do when you're graphing. So the way that I teach it, because I think that the math behind it is very important, is understanding all of these concepts. And if you are confused by anything that I'm saying, please feel free to let me know, and I'm happy to explain everything again and to go over stuff, okay? So let's just pull this up here. Wonderful. So move this over here. Okay, so let's try a problem here. So we're going to put the problem here. Solve slope for equation of line 2. Just give me 1 second to write this out here, guys. And -7, -48. Okay, so let me just move this over. And to -10. Okay, so we just learned about the slope formula, and what we need to do now is apply that slope formula to the problem that we are solving here. So the question here says, solve slope, or solve the slope, for equation of line passing through 2, -10, and 7, -48. Basically what this is saying to us is that these are 2 points that exist on the line they're asking us to solve. So easy peasy, we can definitely solve for that. So I always like to solve lines in the y equals mx plus b format. But within that format, we need to solve for the slope, and the slope is m. And again, just like we just learned, we know that the slope for m is y2 minus y1 over x2 minus x1. Okay, so all very good to keep in mind. So let's use this formula now. Again, if you're given this question on a test, I highly recommend taking the 2 seconds that it takes to rewrite this, just so that you have something that you can actually use for what we're about to do. So I'm going to go ahead and I'm going to label these, and labeling them is super important. So x1, y1, and this is going to be x2, y2. Okay, so when we're plugging into our equation, remember we've got y2 minus y1 over x2 minus x1. Let's go ahead and plug that in. So y2 is negative 48, and that's really important to write in the negative. This is something a lot of people get confused about on tests. If it's negative in the point that you've been given, you have to write it as a negative, okay? So y1, we've got right here, is negative 10. That means that we are subtracting negative 10, and you have to write it in this integer format so that we can simplify it. Great. So now let's take a look at the x's, sorry. So x2, and again, there's no confusion because we are very, very much outlining everything. x2 is negative 7, and x1 is positive 2. Okay, so this is not its most simplified format, so we're going to go ahead and simplify that. So let's go ahead and do that. So we've got negative 48, and this right here, the negative minus the negative, that's going to become positive, as you guys know from your integers unit. So we've got negative 48 plus 10, and if you're confused by that, please feel free to let me know. We can do a little lesson on integers there. So that's 10. I'm going to erase that to draw it properly here. Give me 1 second. There we go. So negative 48 plus 10, and then we've got negative 7 minus 2. So now that we've got that, we can go ahead and simplify that. So negative 48 plus 10 is going to be negative 38 over negative 7 minus 2, which is going to be negative 9. So these negatives are going to cancel out, and we've got 38 divided by 9. So in this case, I'm actually just going to leave this the way it is because it's easier to have it as a fraction. And this is actually something that I highly recommend in general in math, is keeping things as fractions. Trust me, it's a lot easier than doing anything with decimals, okay? Fractions are the most correct type of answer. Always try to reduce them if you can. In this case, we cannot, so we're just going to leave that. So in this case, we know that the slope is 38 over 9. And that means that this is the rise over the run, meaning every time you move over in terms of the line, you're going up 38 and across by 9. And it's positive, so that means we're going to go up and positive, okay? So we're going to go one step further and actually solve this whole equation, okay? And it's actually not that difficult. So if we remember, our equation of a line is y equals mx plus b, which means the y value is equal to the slope times the x value plus the y-intercept. Okay, so solving for this equation is not as crazy as it seems. It's really something that a lot of people freak themselves out about, but really you guys do not need to worry because there's some simple steps to solving it, okay? So let's take a look at this. Well, I already know what my slope is, so I can just go ahead and plug that in. So I'm going to leave everything else as unknown for now, because that's what the letters mean. It means that we don't know. And the very simple solution to solving for the b term, which is the y-intercept, is literally just plugging in one of the points that we got in the original part of the question. So let's take a look at that. We've got, let's plug in 2 and negative 10. So remember, 2 is our x and negative 10 is our y, okay? So we want to plug those in. So negative 10 goes in the spot where y was, and 38 over 9 stays because that's a term that we know. We're going to plug in the number 2 here, and we still don't know what b is, but that's okay. We're going to solve for b algebraically. So I'm going to erase some of this stuff here. Hopefully you guys have had a chance to write that down if you are following along. But if not, just feel free to send us an email and we can explain everything for you a little bit more. Okay, so let's bring this over here and take a look now. So we've got negative 10 equals 38 over 9 times 2. So we know that with our fraction rules, this is really looking like this. And if you are confused by this multiplication with the fraction, I highly recommend practicing your fraction rules. It is something that you're going to need to be really, really efficient at and really good at doing by the time that you are done grade 9 and grade 10. So I highly recommend to always keep on top of working on your fractions. So this becomes 38 times 2 is 76, divided by 9 plus b equals negative 10. Okay, so first I'm going to ask myself, can I reduce this in any way, or can I multiply everything by 9? First I'm going to see if I can reduce this fraction. So if I've got 76 divided by 9, I'm assuming that it might be reducible, but it might also not be. Let's just take a look here. No, so we cannot reduce that. So what I'm going to do is just isolate for b now. So we're going to go ahead and say negative 10 equals, move this over, negative 10 minus 76 over 9 equals b. And basically we want to make sure that these two things have a common denominator, because this is technically negative 10 over 1. And we're just going to go ahead and go here. So that's going to be negative 90 over 9 minus 76 over 9 equals b. And we're going to get negative 166 divided by 9 equals b. And in this case, I'm going to see if I can reduce that. I cannot. So b is going to equal negative 166 over 9. So this is a bit of a more convoluted question, but it's important to understand these skills. So hopefully if you guys have any questions about what we're working on, please feel free to send them to me, and we can take a look at that. Okay, so remember that understanding what a slope is really important. And just, there's going to be a lot, and I cannot stress this enough, many questions that are word problem questions in this unit. Okay, so understanding how to solve word problems is a really big part of doing well in this unit, but also understanding what these things are makes a lot of difference. So let's take a look here. Time. So you're going to get word problems that look like this one. And you're going to get things like 0.2, 5, 10, 15, 20. And then we've got 1, 2, 3, 4. Okay, so let's take a look at this. Remember from the very beginning of this lesson, we were saying to ourselves, okay, well, what's the difference here? Well, this is going to be a difference of 0.8. This here is going to be a difference of 1. This here is a difference of 1. And this here is a difference of 1. So the question is this is a bike, by the way, is the bike going at a constant speed? This is a really, really important question type that you're going to see over and over again, okay? So is the bike going at a constant speed? Well, let's take a look at our first differences. If the first differences are equal, then that means it is constant. If they are not equal, which they are not in this case, then this is not constant, okay? That's really important to understand, because in this case, we want to understand that ultimately it's not going upwards in the same amount each time, okay? So from here, if we don't consider this part and look only at this, then it is constant, okay? So let's pretend that we're looking just at this, alrighty? And we're going to move ahead and take a look at what speed is the bike going. Well, if they're asking you what speed, they're really asking you, what is the slope? Okay, so let's go ahead and solve for the slope. So realistically, one thing that I tell kids is remember that even though this is a t-chart, what you're really given are points on the line. This is x and this is y, because time is almost always going to be your independent variable, which means that it's not affected by anything else because time just goes on forever. That's not always true, but it's mostly true, especially at your grade level right now. Okay, so these are the points on the graph. Alrighty, what we want to do is make sure that we know how to plug these into our slope formula. Okay, so we want to know what speed is the bike going. What they're really asking for here is what is the slope. Whenever you see something like that, that's really what they're asking for, because speed is obviously just going to be distance over time, which in this case is just like saying the change in y over the change in x. This little sign means change. Okay guys, so let's go ahead and solve this question. So what speed is the bike going? We can definitely solve that because we have all the tools to do so. We learned them just now. And again, if you are new to the chat or new to the live stream, just feel free to leave any questions that you might have in this part into the chat. Okay guys? So if we're looking at this, we're going to say, well, we want to solve this line in y equals mx plus b format. Wonderful. And we are right now looking for the slope because we want to know the speed. Well, what is our slope formula? Our slope formula, which is always the easiest way to solve for this, is m, which means slope, is y2 minus y1 over x2 minus x1. Well, that's all fine and dandy, but let's just take a look here. So I'm just going to try to expand my screen a little bit. Maybe it'll make things, give us some more space. Hi, Roman. Yes, this is grade 9. We're going to be doing grade 10 in the next hour. And then grade 11 is at 4 o'clock, and grade 12 is at 5 o'clock. Okay? So if you are in grade 9, you're welcome to join. And this stuff is all from the grade 9 curriculum. But if you're in another grade, you're welcome to join us at the next hour. So every hour is a different grade. So we try to separate things so that people can get the specific help that they are looking for. Okay, so let's go ahead and plug everything in. So first thing I want to do is pick 2 points. So I'm actually going to change the color of my pen here. I'm going to pick this point, which was 5, 1. And I'm going to pick this point, which is 15, 3. Okay, so they don't have to be the points that are one after the other. They can be 2 random points. It doesn't matter as long as you're picking 2 points that are literally on the line, okay? And what we're going to be doing is we're going to go ahead and label these. So each point is numbered. So we have x1, y1 for that first point, x2, y2 for the second point, and we're just going to plug stuff in. So for y2, I've got 3. Got that right here. y1 is 1. And for x2, I've got 15. And for x1, I've got 5. Okay guys, it's really important, and I cannot stress this enough, that you do label these, because a lot of people think, oh, I'm just going to remember which one is x1, which one is y1, and which one is the x2 and which one is y2. But then they get themselves confused. It's not worth it. It takes 2 seconds to label them, and you will save yourself a lot of stress. So I've got this, which is 2 over 10. I can reduce that because that's the same thing as saying 1 over 5. And so my slope is 1 over 5. Okay, so this is the first part. Great. Well, this actually answers the question of this is the speed of the bike, because the speed is really just distance over time. And if any of you guys end up taking physics, you will learn all about this. Speed is just distance over time, and in this case, that's what we did. We saw the change in distance, which is the change in the y, and the change in the time. Okay, so let's go ahead and do something else. So we've got our slope. Wonderful. So let's plug that in. So I've got y equals 1 over 5 x plus b. And there's a very easy way to solve for everything else. If you guys remember from the stuff we were looking at before. And if anyone remembers, it is literally as easy as pie. You just pick a number, pick a point that's on the line, and plug in those points. So in this case, I really like the point 5, 1, and this is its x and this is its y, just as we know points always are. And I want to solve for my b term. Well, let's go right ahead and do that. So if I know that my y, and I'm going to rewrite this so that it's a little bit easier for you guys to visualize. If I know that my y is 1, then I'm just going to plug 1 in here. And if I know that my x is 5, I'm just going to plug 5 in. I always knew that the slope is 1 over 5, or not always, but we solved for that. And then all I have to do is solve for b. Okay, so let's go ahead. So I've got 1 equals 1 times 5, because remember, this is something that confuses a lot of people too. Don't forget that any number, doesn't matter what the number is, if it's just a number by itself, it's technically over the number 1. So this now becomes this, 1 over 5 times 5 over 1. Well, we multiply the numerators and we multiply the denominators. So 1 times 5 is 5, 5 times 1 is 5, and I get 5 over 5 plus b. Great. Now all I have to do is simplify that. Well, 5 divided by 5 is 1, so I'm just going to go ahead and say 1 equals 1 plus b. And in my final step, all I have to do, just going to get rid of that quickly. In my final step, all I have to do is isolate for b algebraically. So all that means is just move this 1 over to the other side of the equation. So this is going to now become 1 minus 1, because on this side it is positive. So that's what we have to do to get rid of it. And everybody learns algebra differently, but this is a very simple way to show this. And then we know that b is 0. Okay, well, what does that mean? Let's take this information and plug it back over here where it's going to matter to us. So we know that the equation of this line is y equals mx plus b, so the slope m is 1 over 5 plus 0. Another way of showing that is just writing it like this. You'll see a lot of teachers that just leave it like this. So this is our slope, and this is our equation, I mean. So that means that I also know something else. I know that my y-intercept is right here at 0, 0. How do I know that it's at 0, 0? Because you're saying, a lot of kids will say, oh, well, you just know that it's 0. Well, I know that the y-intercept always happens here when x is 0. So if it's 0, then that means that it's actually 0, 0. Okay? And then we can say to ourselves, okay, there's a couple different ways that I could draw this. Obviously, you were given all these points in the beginning, and sometimes you are and sometimes you're not. Sometimes teachers will make things a little bit harder and they're going to give you a word problem to solve. So let's go ahead and figure this out in terms of graphing it. So if I know that my slope, just going to get rid of that, let's erase that. If I know that my slope is 1 over 5, that means that the rise is 1 and the run is 5. Okay, guys, I hope this makes sense. And if you're confused by anything, feel free to ask, okay? Leave it in the comments there. The y-intercept here is 0. Okay, but knowing what the y-intercept is, let's go ahead and solve for this slope. So basically we're saying to ourselves, the rise is 1, so we go up 1, and then the run is 5, which means we're supposed to move over by 5 points. So 1, 2, 3, 4, 5. So there we go. And just like we've got here, our first point is 5, 1. Okay, so if I was to draw this line, trying to make it so that it would actually work. And it would go like that. So this particular Cartesian plane that I've got is not wide enough for us to show the whole thing, but, oh, let me just erase that. It's going to erase that whole thing, but that's okay. So when you're graphing these, you definitely want to make sure that you're showing your teacher that you understand what it all is. So you want to show your teacher that you understand that this is the line for this particular equation. Okay? So I'm hoping that that makes sense for you guys. We're going to go on to something related to this, but that's a little bit more difficult because I know that a lot of people get really confused. But what I'm trying to illustrate here is that no matter how you're presented these types of questions, it's very easy to solve them if you know how to do the slope formula. So y2 minus y1 over x2 minus x1, all you have to do is plug stuff in and solve for it, right? And there's lots of different ways that you'll be given equations like that. One thing I do want to move over to, and we will probably try to come back to what we were just working on, but that's really only if we get a chance, is when a lot of people have been asking me to solve questions like this on here. So say that you were given an equation and told to put it into SlopeIntercept form and state the slope. Hope you guys can read my chicken scratch writing here. Okay, so let's say that we were given this question A, okay? So say we were given 3x plus 2y equals 6. Well, this is in standard form. And it's really important to understand how we can get it into the format that we need for what we are learning. So we want it to be, so right now I'm going to show you kind of what the basic understanding of this format is. So this format is like saying ax plus by equals c. And we want it to be in the format, we want to convert it y equals mx plus b form. That's a y. Equals mx plus b. Okay, so a lot of people are really confused by these, and that's why I want to go over them. And we only have about 17 minutes left, so we're going to try to do some of these, and then we're going to try to bring everything together. Okay, guys? And again, we're going to go over linear relations again next week because they are one of the most important, it is one of the most important topics that you're going to learn in grade 9, and it is an area that a lot of people struggle with. So I want to make sure that we cover all the different topics within this unit. So we're trying to convert to this. Well, let's go ahead and do that. I'm going to move these so that we can show our steps. So what's the biggest part of the y equals mx plus b format? The main part that we need to be concerned about is that we want y to be on one side and we want everything else to be on the other side. And that's not that hard to do. So remember in algebra, when we're trying to isolate something, we use opposite operations. So what I'm trying to get rid of is this 3x. I want to move it to the other side. I've already got a number on the other side, which is great. And I don't need to move that number because I already have it on the correct side. Okay? So if we're trying to get this to be into the y equals mx plus b format, we're already partway there because we've got 6 over here. So if I'm trying to move my 3x, I'm going to go 3x minus 3x on both sides of my equation, just like in algebra. Because I did minus 3x on this side, I have to subtract 3x on this side. So here this cancels out because 3 of anything minus 3 of that same thing are going to cancel. And I'm left with 2y. So we've got 2y equals, and I'm going to rearrange here because we want this to be in the right format. So 3x, negative 3x plus 6, and we know it's a plus because here there was nothing in front of it and we automatically assume that it's a positive. Wonderful. Part of the problem right now is that I still have this situation going on. So how can we solve for that? Very simply. Okay, guys, all you have to do is get rid of that 2. Well, algebraically, how do we do that? We can divide 2 off of everything. And remember, when you do it to one side, you have to do it to everything on the other side. So we've got this canceling out. And all that I'm left with here is y equals negative 3x over 2 plus 3. Simple as pie, and you're very much welcome to just leave it like this. And that's your final answer. So here we've got the equation. It's in slope-intercept form. Well, what do we need to know? We need to state the slope. Well, the slope here is equal to negative 3 over 2. A lot of people always assume that you're supposed to put the x in there. You are not. The x is a different thing. Okay, so this is our slope. So hopefully this makes sense for you guys. We're going to try another problem like this. So let's go ahead and do that. If you guys are following along and you've already taken the grade 9 course, this is awesome that you guys are joining us, and we highly recommend that you also join us for the grade 10 hour if you would like to. There's no force here. It's going to help you by being exposed to the grade 10 concepts in advance. It's actually a really great way to get ahead. Okay guys, let's try this again with something that looks a little bit different than what we just did. So say we have 3x plus 20 equals negative 4y. So in this case, you have people concerned oftentimes about how they're going to go ahead and figure all of this out. I like to say when we're learning algebra, do not move stuff around if you don't have to. If the y is already isolated, you can just keep it the way it is, okay? But in this case, we've got this negative 4, and that's a bit of a problem for us because in the y equals mx plus b formula, y is by itself. Okay, we don't want anything in front of y. We want it to be 1y. Okay, so let's go ahead and divide negative 4, and remember, the negative also has to come off as well, off of both sides. So what's that going to give us? Well, we're going to have this cancel, so all we're left with is y. And here we've got negative 3 over 4 x. The negative goes kind of on the top there. It's important to know that. And then we've got minus 5, because positive 20 divided by negative 4 is going to be 5. And we can actually switch this equation around, and it means the same thing. So it can look like this, minus 5. And we know that the slope is equal to negative 3 over 4, so this is going to be a negative equation. And we know that the y-intercept is negative 5. Okay, you guys, so this is our final equation, and then these are the final answers for slope and y-intercept. So hopefully that makes sense for you guys. We're going to do one more problem like this, and then we're going to go back to some more complex stuff. So let's take a look here. And just erase all of this stuff. Okay, so we're going to do one that's a little bit more complicated, and if you are following along, I highly recommend writing these examples down because it will give you something to look back at later when you are, if you're practicing this on your own. So let's take a look here at an equation. Let me just pick one that is a little bit harder. Okay, so let's do this one. We've got negative 2y minus 10 plus 2x equals 0. Okay, so this looks more complicated than it actually is. All you have to do is move all of this stuff over to this side because, again, we want to isolate y. Okay, so let's go ahead and do that. If we've got our original question written down, so I've got negative 10 plus 2x equals, and then we've got 0 over here. Well, what's really going to go on here is we're going to solve this algebraically by adding 10 because the opposite operation is positive. And in this case, we're going to subtract 2x. Excellent. We have to do that to this side as well. So I'm going to add 10 and subtract 2x. this cancels, this cancels. You're left with negative 2y. And on this side, you're left with this stuff. So we've got negative 2x plus 10. But we have not solved this equation fully because we still need to get rid of that negative 2 from the y that's attached to the y. So right now this is technically negative 2 times y, and we're going to do the opposite operation across all of the terms in this. Okay, so let me just pick another color here. And we're going to divide negative 2 off of everything. Okay, make sure that you divide off of every single term. So this cancels here, we're left with y. Here we've got negative 2 divided by negative 2. Well, any number divided by itself is 1, so all I'm left with is 1x. And here, positive 10 divided by negative 2 is negative 5. Okay, so let's take a look. What is our slope in this equation? It's actually very simple. It's just 1. Technically it's 1 over 1 because every number by itself has a number like that. And then the y-intercept is negative 5. So for those of you who stuck around today, what we're going to be doing next week is actually looking more at word problems and how to solve word problems in this area, because that's where things get very dicey for a lot of people and makes it a little bit harder for people. Okay? So let's say that you're given this question. Let me just pull this up. So, given the slope and y-intercept, write an equation of the linear relation and graph the line. Okay, simple enough. We can definitely do that. Let's pull in one of our little Cartesian planes here that I've got mocked up over here. Expand this guy. Oh, let's just do this. Bring this guy over here. Perfect. Okay, so let's go ahead and do that. So let's say I gave you a slope of 2 over 5 and a y-intercept of negative 5. How can we go about solving this? It's actually really easy, you guys. Again, following the steps. Don't psych yourself out. You're much better at math than you think you are most of the time. So it's a lot better to just remember, okay, what are the steps, practice the steps, and go ahead like that. So first of all, let's put this into our y equals mx plus b equation. So we know that it looks like this. And I can just go ahead and plug these numbers in. And I know that this is my situation. Okay, so this is the first part of the question. We've written the equation of the line. Excellente. Now what we need to do is go ahead and graph this line. Well, I already know one of the points on my graph. Very simply, because I know the y-intercept. The y-intercept is negative 5. That point is always going to be, oh, sorry, my bad. Let me fix that. This point is always going to have x as 0 and the y term like that. So let's take a look at that over here. We've got 0, negative 5, which is right here on the Cartesian plane. So that's our one point that we do know. And then I'm going to go ahead and pick another number. So I'm going to go ahead and pick the number 5 as my x. So let's do that. So pick an x value and plug it in. Some people like to actually just go on here and do the graphing. That's fine too if you want to move up by 2 and over by 5, yada yada yada. That's fine too. It's just that this is easier for the most part for most people. Okay, so here's my equation. I'm going to pick x is 5. And I want to know what is my y. So all I have to do is plug that in. So 5 minus 5. Okay, great. So let's go ahead and do that. So y equals 2 times 5 over 5 minus 5. And that's going to give us y equals 10 over 5. minus 5. And that's going to be 2 minus 5, which is negative 3. So this makes my point 5, negative 3. So let's go ahead and plug that in here. Wonderful. And then you can choose another line as well. It's totally up to you. Basically, usually I suggest plotting 3 points. In this case, it's probably not going to happen for us, but if we were to just go 2 up, 1, 2, and then 5 over, we know that it would be somewhere over here for us to get a straight line. Okay, so let's plug that straight line in. So again, you want to make sure that it aligns with your points. There you go. This is our equation for y equals 2, sorry, that's our graph, I mean, for y equals 2 over 5, x minus 5. Okay, now I know you guys are not writing EQAO this year, so it doesn't super matter in terms of EQAO, but this does matter for next year. It does matter for the year after that. Every single year that you're going to be learning math, you do need to recall this information. So it's important to go over this as much as you can. Okay, guys? So let's go ahead and do one more example like this. So actually, let me bring in this Cartesian plane first. Let's do that. And take a look like this. Oh, it made my, no. Give me 1 second, you guys. For some reason, it logged me out of this. There we go. Okay, so let's plug that in. The text here. Great. And just put this over here. So let's do this. We've got 3 minutes. We can definitely do this. Okay, so let's look at question B. So question B is where they have given us m equals -2, b equals 1. Wonderful. Let's plug this into an equation. Y equals mx plus b. Simple enough. We can just take this and plug it here, and take this and plug it here. Great. Let's do that. -2, x plus 1. Wonderful. So we've got that. Now that we have this, first of all, I know what my y-intercept is. I know that that bad boy's right here. That's our y-intercept. Because again, when x is 0, that's where you have your y-intercept. And now all we need to do is find 2 more points. So I'm going to pick, let's say, let's pick the number 2. So this is -4 plus 1 for y. So y equals -3. So we've got this here. So 2. So our point here is 2, -3. That's that there. And then let's do one on this side. So let's do -3. So that's point A. And then let's plug in -3 as our other type of value. So we've got -3 as our x plus 1. And then that's -6 plus 1. Oh, this is a negative, sorry. So this is +6 plus 1, which is 7. So I'm going to look at -3 on the x-axis and go up to 7, which is over here. And now I can literally just take this and put in a line. And it's not solving world hunger, but it is solving this problem. So, dad jokes aside, this is a very good strategy that you guys can use when you're given questions like this. Remember, it's not as crazy as it looks. You can always, always, always just take it step by step and you can solve. So that's everything for the grade 9 class today. Thank you so much for tuning in. We're here every week at the same time. So again, if you have questions, feel free to bring them into the chat. If you want to email us your questions in advance, you can. You can send them to us at admin@scholarlyelite.com. But we are going to start with the grade 10 class now. And if you want to stick around, you're more than welcome to. Okay, guys? So thank you so much. And I want to say welcome to any grade 10s that might be watching right now. So just getting started here. Let me just pull up the grade 10 materials that we're going to be working on, you guys, and we can get fully started with the grade 10 class, okay? So, this week for the grade 10 class, we are going to be working on a couple different things. We've got some submitted questions that were submitted by students who watched during other weeks. We've got some questions. Well, we're also going to be teaching a lesson. But I want to make sure that if you did submit a question to us, please just leave a comment in the chat saying that you're here so that we can make sure that we're addressing the questions while the right people are actually watching. So let's do this here. So again, if you're just tuning in now, welcome to the grade 10 chat, to the grade 10 live stream. We are here to help you guys as much as we can with any questions that you might have. And what that really means is basically answering any questions that you submit into the chat and showing you guys a lesson on some of the key skills that you're going to need for grade 10. So the lesson this week is going to be about quadratic equations, and in particular we're going to be talking about the vertex form and what that means and how we go about solving for it and all of that fun stuff. But before we do that, we're also going to talk about what are the roots of an equation and all of that fun stuff. But we're going to get there. So we might not actually get to vertex form fully today, just depending on how long all of the questions take. But we will try to get there at some point. Okay? So first and foremost, what I want us to talk about today is what really is a quadratic equation. So I'm going to put this right in the middle here. And when we talk about a quadratic equation, what we're really saying is that it has the term x squared in it. So we want to take a look at the original quadratic equation, which is this: y equals x squared. Every quadratic equation that you're going to encounter is some variation on this original quadratic equation, okay? So as many of you guys who may have already learned this in class, if we have our x and y chart and we know that y equals x squared, right? So say I'm looking at 0, 1, 2, 3, 4. Okay, so 0 squared is 0, 1 squared is 1, 2 squared is 4, this is 9, this is 16. Cool. The same thing applies for the positive and negative side. So in this particular case, positive and negative 1, positive and negative 1, positive and negative 1. So just remember that our original quadratic equation looks something like this. Well, looks exactly like this. So 2, 4, 1, 1, 4, 3, 9, which is way up there. So, wow, my art skills. For those of you guys who've been here a couple weeks now, you know that my art skills are not the best on the computer, but we are trying our best. Okay, you guys. So, let's take a look here. Let's go. Great. So, let's pretend my art is beautiful and wonderful. And we've got y equals x squared here. Okay, you guys, so I just want to show you this so that we can have a basis for what we're going to be talking about for the rest of the hour. So just remember that when we're talking about a quadratic equation, whether or not it is in the exact same format, meaning, you know, we're going to look at quadratic equations that are a little bit more complicated, they all have this as their kind of root equation, okay? So we've got three forms of the quadratic equation, and every quadratic equation can be mixed between these forms, basically. So, or not equations, quadratic. Yeah, we're just going to call them equations. So let's take a look here. We've got y equals, actually, let's start with our quadratic form. So in the quadratic form, we've got y equals ax squared plus bx plus c. In our vertex form, we've got y equals a x minus h squared plus k. And I like to call this Hong Kong. That's how I remember that. And then we've got factored form, which is y equals x minus p, x plus q. Okay, each of these formats tells us something different, but every equation can be altered to match each of these formats. And what that really means is, like, say for example, I have an equation like, for example, y equals x plus 3, x plus 2. Well, this tells us what the x-intercepts are. And I'm going to go into that a little bit further today. But it also can be transformed into our quadratic form very easily. You just multiply everything out. So this is going to actually become y equals x squared plus 5x plus 6. And that is the quadratic form right there. And we're not going to go into how to do vertex form if we don't have time just yet, but you can also convert this into vertex form. And the whole point of knowing, the whole reason why we convert between them is because each format tells us something different. So like I was saying, the factored form tells us the x-intercepts for the equation. The vertex form tells us the vertex, which is the maxima or minima. So in this particular case, this is an upwards opening. It would look something along the lines of, and don't fully quote me here because this isn't going to be perfect, but it's going to be something along the lines of -2, -3, and the vertex is going to be, which is going to be -5 divided by 2, 1, so -5/2. So it'll be something like over here, and these are going to be like this, right? And this is -3, -2. Okay, I'm just kind of brushing over that because we're going to get further and more intricately aware. We're going to become more aware of how to do all of this. I don't want to confuse you guys to start out. I just want us to understand that each format of the quadratic equation has its own purpose. We can convert between the various formats very easily, and we're going to learn how to do that these couple days, or this next few weeks. But it's important to understand what each one tells you. This one tells you the maximum or minimum. This tells you the x-intercepts, and actually the quadratic form is kind of useless except for a couple things, but we're going to talk about all that. Okay, so like I said, if you guys have any questions, feel free to submit them in the chat. It doesn't have to necessarily do with what I'm talking about. You can submit any questions, but if it is about what I'm talking about, please try and submit them as soon as you think of them so that we can address them while we're still close to that topic. Okay, so before we go fully into our lesson today, I did have some questions submitted that actually kind of pertain to what we're talking about. So it's important that we kind of address those before we move on. Okay, guys? So let's take a look here. So we had some questions submitted that have to do with factoring. And we were doing factoring last week, so we're going to take a look and do a little bit of a review before we move on to understanding each format and everything. Okay, so let's say we do this type of question. So if your teacher gives you this type of question and tells you to solve, what they're really asking, and again, it depends on your teacher. Some teachers, when they say solve, they mean just find out the factors. But most teachers, when they say solve, really actually mean that they want you to solve for the x's and solve for what the equation is and solve for what the roots of the equation are. Okay, guys, so let's go ahead and try this one. So we've got 3 times 9. For anyone who missed last week's lesson, we're doing factoring by grouping, and I use a term called the air conditioning method. So we've got 27. So 3 times 9 is 27. We want something that adds to 28 and multiplies to 27. Simple enough. Great. And we're going to take these two things and basically split up this 28 into two separate things. So we've got 3x squared plus 27x plus 1x plus 9 equals 0. And then we're just going to go ahead and do that split and factor these guys. So we've got 3x x plus 9, and we want the factor on this side to also equal x plus 9. So we're going to be factoring out the number 1. Okay? Now, let's take a look at the next step. So what we want to do is create two factors. And this was something that we did get a couple questions about over the weekend about how this next factor is created. So this next factor, whatever you factored out, that creates one factor. And whatever was here, that's the other factor. So these are our two factors. Now, basically, because they're equal to 0, we know that we can solve for x. So we make each factor equal to 0. So let's go ahead and use a different color here. And we're going to solve for x. So basically, each factor can now be made equal to 0. So we go 3x plus 1 equals 0. And we're going to solve for x. So simply enough, all we have to do is solve algebraically. So this is divide by 3, divide by 3. We've got negative 1 over 3. Very nice. So that's our first solution. And then we've got our second solution, which is going to be x plus 9 equals 0. And we just solve for x. So that's going to be x equals negative 9. And if your teacher's fancy, sometimes they'll ask you guys to write these as actual points on the graph. So just remember that these are x-intercepts. So all you need to remember about that is that the y term is always 0 when it's an x-intercept. And we've got negative 9. And there you go. You've got your two x-intercepts. I hope that makes sense. We're going to do another example like this. This was another one that was submitted. So let's say you're given this crazy question. And we were doing something similar in the grade 9 class. So if you remember in grade 9 when you were converting between standard form for a linear equation and the, what's the other word? And the y equals mx plus b form, this is a similar concept. So again, whenever we're solving for roots, the entire term ax squared plus bx plus c has to equal 0 in order for you to solve for those roots. So that means we want to get everything over to one side. So how do we do that? Simple enough. All we have to do is literally just move everything over. So algebraically, we know that this is negative c squared on this side. So on this side, it's going to become positive c squared. And then that makes this side 0 because there's nothing left on this side for us to deal with. So we know it has become 0. And then we can go ahead, now that this is equal to 0, now we can go ahead and solve for these. So we've got 15. And in this case, actually, it's just a standard one. So we can go ahead and just get c plus 5, c plus 3. And always check these. Again, we did this lesson last week, so I don't want to go over things too many times within a close time span in terms of showing all the steps. We will over the weeks because the likelihood is that, you're definitely not going back to school before the beginning of May, and we still don't know what's going on after that, but we're going to have a lot of time to go over things. So again, if you were to multiply this out using the FOIL method, you can actually see that it does equal this. And then we just go ahead and solve for these. So c plus 5 equals 0, which is c equals negative 5. C plus 3 equals 0, which is c equals negative 3. And we've got that. And those are our final solves. That means that our x-intercepts take place at negative 5, 0, and negative 3, 0. Okay, you guys, I hope that makes sense. If you have any questions, feel free to leave them in the chat. So let's take a look here at one that's a little bit complicated as well. So let's see, let's use a different color, feeling fancy here. So let's take a look at this question. So say your teacher gave you this question and said solve -5 equals 2p minus 16p squared. Okay, well, again, our goal here is to get everything over to one side. We want one side to equal 0 and everything else to equal whatever's on the other side. So in this case, I like to change everything to positive as much as I can, especially the a term. So if I'm going to look at this question, I'm going to want to move this over here. I'm going to want to move this over here. So let's go ahead and do that. So this was negative on this side. So on the other side, it's going to be positive 16p squared. This is positive on this side, so it's going to be negative 2p on this side. And this guy didn't move, so he's chilling. Equal to 0. So now that we have it equal to 0, we can just go right ahead and take a look at everything by factoring it. Because again, when we put it into factored form, it tells us our x-intercepts. It tells us where this lies on the x-axis, or where it intersects at the x-axis. So let's go ahead and do that. I cannot factor anything out of all three terms. So what I'm going to do is do my air conditioning method, and we've got that here. This equals -80, and this is going to be, sorry, just one second, guys, positive 16p minus 5. Yeah, okay, so we've got -80, so we want two things that multiply to 80 and add to negative, so that multiply to -80 and add to -2, so we've got -10 and +8. Great, so let's take those things and plug them in. So again, sometimes it's trial and error, but really it's just about kind of saying, okay, well, 8 and 16 kind of go together, 10 and 5 go together, so we're going to do that. So we're going to go 16p squared plus 8p minus 10p minus 5. So all equals 0. Let's go ahead and split these guys up. Now in this case, what we're going to do now, so this is a little bit different than what we're used to because this first number is bigger. That's totally fine. As long as the two factors that you're creating are identical, it actually doesn't matter if that first number is larger. So I'm going to be able to take out 8p from here, and if I'm doing that, I'm just going to show you guys here that that's what I'm doing. And so what I'm left with here is 2p plus 1, and I know that my other term is going to have to be the same. So what do I take out of here? Well, I know that I'm going to have to take out -5, and by subtracting out -5 from both of these, that's how I get 2p plus 1. And then my final factors are going to be 8p minus 5 and 2p plus 1. And bring that up and over so we can solve for our x's. So let's do that in a different color. Or p's, sorry. So we're going to make them both equal to 0 because this whole time they've been equal to 0. And we know that. So 8p minus 5 equals 0. We're going to isolate, and we know that 8p equals 5. P equals 5 over 8. That's one of the answers. And we know that that's going to be 5 over 8, 0 as a point. And then we've got 2p plus 1 equals 0. And we've got this isolated, so same concept, this is -1 over 2. And that's our other root, aka our other x-intercept, which we know the y has to be 0 for. Okay, so I hope this is making sense for you guys so far. We're going to do a word problem in this regard as well. So I'm just going to open up another page and type out this word problem so you guys can see it. But if you guys have any questions about this, feel free to submit them in the chat, okay? So this is a very common type of word problem that you guys are going to see. So the length of a rectangular plot of land is 7 meters greater than its width. The diagonal is 8 meters greater than the width of the plot. of land. What are the dimensions of the plot of land? Okay, so let's bring this over because I know that we can't really see what this says right now. Whoa, what is even going on here? Okay, let's bring this here. Sorry guys, I'm trying to make this so you can actually read it. Okay, great. And then let's just... Great. So let's take a look at this piece by piece. Okay, you're going to get a lot of questions like this. This is not the only year you're going to get questions like this. It's going to be all the time. You're going to see them a little bit more complicated in grade 11, but it is important that you understand it in grade 12, in grade 10 as well. Okay, so we've got the length of a rectangular plot of land is 7 meters greater than its width. The diagonal is 8 meters greater than the width of the plot of land. So first of all, before I start anything, when you're doing a word problem like this, we want to take a look at a very specific word problem formula that I like to use that's called GESA. Okay, this helps you break down word problems into a little bit more, understandable steps and just makes things a lot easier. So when you have the GESA formula, you ask yourself what has been given, what is unknown, what's the equation you're going to use to solve, then you do the solve and you show the solution and then you write your final answer, which is usually a word, like a sentence is what I'm trying to say. Okay, so in this case, we're asking ourselves, what has been given? Well, we've actually been given quite a bit of information. We know that it's a rectangular plot. You know what? Let's see if I have a rectangle shape in here so I don't have to butcher the idea of a rectangle. So let's see here. Do I have rectangles as shapes? Oh, here we go. Yay! Rectangle. Oh, look at that. Killing it. So great. Wonderful. Okay, guys. Back to business. So, we've got our rectangle there. I'm going to call this its width. I'm going to call this its length. Great. We're also going to need a line here. Just a straight up line for its diagonal. Woo! Wonderful. Good enough. Close enough. Great. So, they've told us a couple of things. We know that the length is equal to the width plus 7 meters. We know that the diagonal is equal to the width plus 8 meters. Well, that's exciting for everybody and for us because it tells us a lot of stuff. So what I'm going to do now is say to myself, okay, instead of calling this length and width, I'm going to change this. Damn it. Make this blue so that my line... Cool. Pretend that line is perfect. We're just going to pretend that didn't happen. We're good. Okay, so we're going to call this part W for width. I'm going to call this width plus 7. And I'm going to call this width, I always say that word weird, width plus 8. Okay, so the first thing I kind of say to myself in a situation like this is, okay, well, what rules do I know that can apply to this situation? Well, I know that when I take a rectangle and I slice it in half like this, I automatically am creating two triangles, both of which are right angle triangles. This here, your boy, he's 90 degrees. Wonderful. Okay, so that tells us a lot of information because we know that we can apply a certain formula to make things make a little bit more sense. How do we apply this formula? Let's go ahead and take a look here. So first, let's address what is our unknown. Well, our unknowns are the dimensions. So what we really are asking for is width and length. Great. Well, let's do that. What's the equation I'm going to use to solve for this? Well, simply enough, the Pythagorean theorem is actually going to be our number one guy in this situation. So if you guys recall the Pythagorean theorem, whenever you have a right angle triangle and you've got a hypotenuse A and then these guys are B and C, we know that the hypotenuse is equal to, so the length of the hypotenuse squared is equal to the sides squared. Okay? Now, what's important to look at here is what are we using for these various terms? Okay, so let's go ahead and solve up over here. So if we're solving and our equation that we're using is a squared equals b squared plus c squared, well, let's denote what everything means. So I'm going to call the length is b, and the width is c, and then the diagonal is a. Why is that the case? Well, because we know that the diagonal is the hypotenuse. Okay, guys, that's really important to remember in this case. So hopefully this is making sense so far. So let's go ahead and take that information and plug that in, okay? So again, we have these up here, if you guys are taking a look. We've got all of our information here. Width is just W. Wow, my pen is having a real moment here. Okay, so let's plug that in. So the diagonal, which we know is here, which is width plus 8 squared, and that's equal to the width plus 7 squared plus the width squared. You can put it in brackets, you don't have to though. Okay, guys, so let's go ahead and solve now. So first of all, when we are squaring stuff like this, what we need to do is actually expand them. So here we're going to have this equal to this here. And if you're confused by that, definitely go back and practice your FOIL rules. Here we've got this plus W squared. Alrighty, so now what we have to do is make sure that we are doing everything we were doing just before this, which is putting everything on one side and making it equal to 0, because that's how we're going to solve for our factors. Okay, guys? So let's go ahead and do that. If I move everything over to one side, actually let's simplify this first. This side is going to become 2W squared plus 14W plus 49. This side, nothing is changing. Great, so let's go ahead and move this side over to this side. It's just going to be easier. So we're going to make it equal to 0 by moving everything over. We've got 2W squared minus W squared plus 14W minus 16W plus 49 minus 64. And we're going to get, and I'll give you guys a second here to just catch up with what I'm doing. So if you're writing this down, let's make that equal. Awesome. Thanks, Roman. Glad you guys have joined. This is awesome. And here this is going to equal W squared minus 2W minus 15. Okay, so now the moment of truth. We want to factor this. And what I am going to do is just move everything up slightly. So we're going to factor this bad boy, and we're going to get W minus 5, W plus 3. And just like before, in order to solve for our x-intercepts, and in this case solve for what we're actually looking for, we need to make these equal to 0. So we're going to go ahead and do that in a different color. Let's say this cute little pinkish red. So let's make these equal to 0. And you know what? I'm going to erase this area because we already get that. You guys are good. Let's make some space for us. Ba-da-ba-ba-ba. There we go. Cool. Let's solve for W. So we know that this is all equal to 0. So we can say W minus 5 equals 0 and W plus 3 equals 0. And in this case, we're going to get W equals 5. And in this case, we're going to get W equals negative 3. So this is the kicker here. Okay, guys, be really careful with word problems when they give you specific real life situations like this. You need to be aware of the fact that you cannot use, where's my little, there we go. Oh my gosh, this thing. You cannot use this negative value because in real life you cannot have a negative width. I hate the word width, but you get what I'm saying. You cannot have a negative width. So it has to be our winner over here. Chicken, chicken, winner, winner, chicken dinner, however you say that. This guy right here, and that means that we know that the width equals 5, and we know that the length is equal to the width plus 7. So that's going to be 12. These are in meters. And then when you're giving your final answer on like a test or if this was an assignment or something, you're going to want to put this into the sentence, right? So the dimensions, I'm not going to write the whole sentence, but the dimensions are that the width equals 5 meters and the length equals 12 meters. So I hope this makes sense. I know that someone had submitted this because they were wondering about it. You guys will definitely see questions like this on exams, on tests, even in future years. So it's really important that we understand what's going on here, okay guys? If you are confused about any of this, again, as you know, feel free to join us and message in the chat, and I am happy to answer that for you. Alrighty guys, so let's take a look at our next situation here. I also did have another question that was submitted by somebody, and I know that they mentioned, their mom mentioned to me that they had solved it, but it is a really good question, so I'm going to actually have us take a look at that quickly. It doesn't fully have to do with this part of the unit, but we'll come back to this, okay guys? So, let me just type out the question here, put this here. So I'm going to say the Mac River is 1056 km longer than the Yukon River. The total length of the two rivers is 7426 km. Find the length of each river. Okay guys, so in the question that this person had sent, they actually showed the formulas, but we're actually going to work together to solve these formulas because you will get questions like this. Oh gosh, this is so weird. Okay, you will get questions like this sometimes that you are not given the formulas for, and it's good to understand how to solve the formulas. So remember that when we're learning and we're doing word problems, we look at GESA, we ask ourselves, what has been given? Well, in this case, I know that the Mac River is equal to 1056 plus the Yukon River. And that the two rivers, Mac plus Yukon, equal 7426. So people who don't really like word problems, this is a really great strategy you can use. So now instead of using these letters, I'm going to literally say, let X represent the length of the Mac River, and we're going to let Y rep the length of the Yukon River. Alrighty, so simple as that. That's all we need to worry about for right this second. Now, what we want to do is take a look here at what we can do with that information. So I already kind of have my stuff written out. I can literally just say, okay, well now this equation is x equals 1056 plus y, and the other equation is x plus y equals 7426. Great. Now, given this information, there's 3 different main methods that we can use to solve for one of each, right? But first, before I do that, So again, we're looking over here. What's our unknown? River lengths. So we really want to isolate for each river length. Okay, so the equation that we're going to use in this case is actually just making the substitution. What does that mean? All right, so when we talk about substitutions, what I'm going to be doing is making both terms equal to the same letter and then using that as a way to plug one letter into the other. So in this case, actually, we don't have to make both terms equal to the same letter. What we are going to do is say to ourselves the following. This here is like saying x is equal to 1056 plus y. Okay, well, if x means the same thing as 1056 plus y, then instead of this letter x, I could actually just take this term and plug that bad boy right into here. Okay, guys? Simple as pie. Literally, that's all you need to do. You're literally just going to take this 1056 plus y, and then this plus y stays where he is, and that equals 7,426. All right, simple enough in theory. Let's go ahead and do the math now. So again, just like with algebra, we want to bring everything together and isolate for the letter that we're trying to solve for. In this case, we're solving for y. And the whole point of the substitution method is to use your knowledge of what one term equals and to literally plug that into the other form, to the other equation, and get your answer by solving for the letter that's left. So in this case, the letter that's left is y. So to simplify this, this equals 1056 plus 2y equals 7,426. Excellente. And then now we're just going to be isolating for y by moving this over to the other side. So that's going to be 2y equals 7,426. Oh, you guys learned that, Roman? Yeah, so we just had this submitted by a student of ours, so that's why we're going over it, okay? We're going to definitely go back to the other stuff we were doing as well. So now what I want to do here is get this answer, which is 6,370. And then we're going to solve for that. So we go y equals 3,185. And so this is only the answer in part, because this here is the length of the Yukon River. Well, we still need the length of the Mac River. Well, no problem at all, because we can just take this information and plug it in right here. And that's going to be 1056 plus 3,185, which is 4,241. So we kind of ran out of space here, but well, let's move all this stuff up and over. Cool. Okay, guys, so our final answer is that the Mac River is equal to 4,241 kilometers, and the Yukon River is equal to 3,185 kilometers. So I hope that makes sense for you guys. I know that this was a question we had submitted, so I wanted to go over that. With the last 20 minutes of our time together today, what I am going to do is kind of come back to what we were originally talking about, which is quadratic equations. Okay, guys? So in the quadratic form, remember that we were saying at the beginning of our session today that there are three main formats of the quadratic equation, and we know that each format tells us something different. Okay? Now, in terms of graphing, it's actually really helpful to understand what each format does. So again, we have our factored form, which is the kind we're focusing on today, that we were focusing on earlier. And our factored form looks like this, y equals, and when you first learn this, a lot of teachers don't show it like this, but the actual truth is that this is the real formula. This A term, still chilling in the front, okay? Really important for us because we know the A term is going to tell us a couple of things. So again, I'm just going to go ahead and pull up this situation. Bring it into our thing here. Okay guys, so let's take a look at a problem that's a little bit more on point with what we are working on here. So let's go ahead and solve, oh, let me just get my pencil here. Let's use green, we never use green. Solve and graph the following quadratic. So up until now we've been solving, but we haven't been graphing. So what I want us to really get into today is understanding how this all comes together and how the knowledge of everything we've done so far plays into what we're learning overall, which is really all about graphing. Okay guys? So let's take a look at this equation. So 0 equals, oh sweet Lord in heaven, there we go. Let's fix this. Sometimes my equal signs just come out looking crazy. Okay, so we've got negative x squared plus x plus 6. Okay guys, so remember in our original quadratic format, this is going to be y equals ax squared plus bx plus c. So it's really important to remember that our a term tells us a lot. It tells us which way the graph is going, whether it's going upwards or downwards. When it's negative, it's actually going downwards. Okay, that's really important to remember. So we know that our graph is going to look something like it's going to look like that somewhere. Not exactly, obviously, that's just kind of an estimate, but it's going downwards. And that means that it's going to have a maximum value. Okay, so let's go back to this and just do the factoring. So when I am factoring, and I have an a term that is negative, this is something, again, that a lot of teachers don't go over, and it's really important. Not to say all teachers, just some. I've spent many years tutoring. So we want to factor out this negative term. So that makes this x squared minus x minus 6. And that makes these two factors x minus 3, x plus 2. Okay, so just like earlier, we're going to solve for our individual x values by making each factor equal to 0. So in this case, we've got x minus 3 equals 0 and x plus 2 equals 0. And we're going to solve here, and we're going to have positive 3. Here we're going to have negative 2. Okay. These are our roots, aka our x-intercepts. Okay, you guys, so it's really, really crucial that we understand that and that we remember that, okay? So, keeping that in mind, that really just tells us where we are graphing and where our graph actually intersects here. So, let's go ahead and plot those. So we've got x equals 3, which this point here is going to be 3, 0, and this point, this is equals. So this point's going to be negative 2, 0. So let's plot that here. I've got positive 3, 0 and negative 2, 0. Now, depending on how far into this unit you are, depending on how you like to approach problems, there's a bunch of different ways that you can solve for this next part. But one thing that is for sure, for certain, is that this graph is going downwards. Okay, guys? So these things, we know for sure, are going to go like this. Right? Again, my artwork is not perfect, but you get the gist of it. What we want to know is, where is the vertex? Where is that middle point? So there's a couple different ways you can solve for midpoints. We will learn about vertex form next week when we have more time to actually do a whole lesson on it, because it is quite complex in that sense. But there's an easier way to solve. Wow, love when that happens. Whoop. There we go. So now we're just going to go ahead and solve for the midpoint. Let's put a line here so we don't get confused. Okay, so there's a midpoint formula. Some people just do the counting themselves, but there's actually a way, there's a method to the madness. So the midpoint is x plus 1, x1 plus x2 over 2, and then this one is y1 plus y2 over 2. So if we have our 2 points, which we know to be like this, we've got the x's, which are 3 plus negative 2 over 2, and we've got 0 plus 0 over dose. Wonderful. So let's take a look here, and we know that our midpoint is going to be a half over 0, or next to 0. So that means that that's right here is where the midpoint is, but that doesn't mean that that's where the actual maximum is. So finding the vertex is as easy as plugging in this x term. And again, we're going to do a different way next week to find the vertex. This is not the only way to solve for it, but this is definitely one method that is good to know, and you can just plug in that vertex. So let's go ahead and do that. So we're plugging in our x's, and it's simple enough. We just have to do this plus 1/2 plus 6, and that's going to get us 25 over 4, which is also 6.25. And that means that I know that at 1/2 and 6.25, I've got the vertex, which is a maximum. Okay guys, so I'm gonna go ahead and connect those dots kind of as best as I can. Oh my god, my drawing is terrible, but basically it's supposed to look like this. It's also important that you go ahead and solve for the y, but I've already done that, so I'm just going to do that. And it's very easy to solve for the y, guys. You just literally have to make x equal to 0, and you're left with positive 6. Okay, so this is our graph. It's not the cutest graph of all time, but it gets the job done. So, and this is the graph y equals negative x squared plus x plus 6. Okay, guys, I hope that that makes sense for you. We're going to do some other stuff as well. And what I want you guys to really be aware of when you're doing questions like this is that it's really not as crazy as it seems. Like I said, let's kind of go through our steps here. First, step 1, we factored. Step 2, we solved for our roots. Step 3, we solved the midpoint. And step 4, used x value of the midpoint to solve for the vertex. Okay, you guys? So let's go through a couple things that your teacher might ask you on a test or on an assignment, because I don't know how you guys are doing tests right now. Let's just move this up a little bit. Oh, by moving it, I ruined it. Oh my goodness. There we go. Hold on. Give me 2 seconds. There we go. Okay, let's just leave that the way it was. So your teacher might ask you the direction of opening. And that's going to be down. They might ask you, what's the vertex? Well, the vertex here, very simple. It's positive 1/2 and 6.25. They might ask you, what are the roots? And it depends on your teacher and how they've taught it to you, but most teachers will accept actual points. So here in this case, you've got -2, 0, and 3, 0. So these are important things to remember. Now, those of us who have been tuning in every week, we haven't talked about domain and range yet, but you might get asked about the domain and range. So if you don't know what domain is all the values of x that can exist in this situation. Theoretically, if this is not a real life scenario where like this continues on forever, because that really is what's happening here technically, right? Theoretically, the domain is all values of x. But the range is where this gets interesting because the range only goes up to this point of 6.25. So we know that it's going to look something like this, y equals IR. And we're not going to get into this today. We can learn this another day because we don't have time to go into that. But basically the range is just y is less than or equal to 6.25. So I know this looks really crazy if someone's just tuning in right now. Basically, it's not as hard as it looks. Like I said, take things step by step, practice these as much as you can, and it'll make your life a lot easier. Okay, guys? So let's try one more thing like that. And if you guys do have any questions that your teachers have submitted to you, please feel free to send them over. That's perfectly fine. We can answer them for you. Let's take a look here. Let's do one of the questions that we were looking at earlier. Let me just pull it up here. So, let's say I was given, actually let's bring this graph in first before we start anything. Great. Okay, so, cool. Let's say I was given something along the lines of like m squared. Actually, no, that's not going to work because that's way too, the values are too high. Let's do, okay, we did this one earlier, but we're just going to kind of speed through it quickly. 18 minus negative c squared. Okay, so say we did something like this. We want to move this over, again, keep things on this side the way they were. And we're going to factor this, so we've got our factors, which are c plus 5, c plus 3, equals 0. Okay, guys, so again, we're just going to make each factor equal to 0. So we've got c equals negative 5, c equals negative 3. Cool, well that actually gives us our x-intercepts, aka our roots. So we know that here we've got this guy, here we've got this guy, and we also know that this is a positive equation, meaning it's going to go upwards and the vertex is going to be somewhere in this quadrant because the graph is going to go upwards. Okay, guys? So let's go ahead and solve that. So this was our step 1. Cool. So if we remember from our last thing, what was step 2? Oh, and then step 2 is solving for roots, which we did. So here's step 2. Cool. Moving on, let's look at step 3, solving for the midpoints. So let's do that up here. So step 3, solve for m, which is our midpoint. So midpoint equals x1 plus x2 over 2. And again, like I said, next week we're going to learn how to complete the square, which is an incredibly important skill that everybody really needs to understand for all of the rest of math. So please, I implore you, if you are having trouble with that, do tune in next week because it's going to be helpful for you. I have a very easy way of learning it, and I hope that it can help you guys. So okay, let's plug these in. We know that our points here, we've got, this is x1, y1, this is x2, y2. Always label, it just makes life easier. So we've got negative 5 plus negative 3 over 2. And here we've got 0 plus 0 as always because these are intercepts. And we get negative 8 over 2, which as we know is negative 4. So actually let's write it like this. Negative 4, 0. That is our midpoint, which makes sense because it's literally in the middle. And then we take that and we go ahead and go here, and step 4 is just plugging this negative 4 into our original equation. So we're going to go 8 times negative 4 plus 15. Oh wait, no, that's not the equation. Negative 4 squared plus 8 times negative 4 plus 15, which let me just plug that all into my calculator. So that is 16. Just give me 1 second. So we've got 16. I don't know why it's coming out wonky. Just give me 1 second. I have a call coming in here. So this should be, I don't know why on my calculator it's coming out weird. Oh, damn it. Minus 32 plus 15. See, but the thing is that it shouldn't equal that, so I don't know why it's coming out crazy. Plus C. Give me 1 second, guys. -4. Oh, okay, I'm going crazy. Yeah, I'm right. This is fine. So this is going upwards. That's why I wasn't sure why it was coming out weird. Okay, guys, so this is going to look like this. Simple as that. Obviously a little bit cleaner. And if you want to be fancy on a test, obviously you should solve for the y-intercept. It'll be somewhere out there. But then this is your equation. Y equals c squared plus 8c plus 15. Okay, you guys? So if you do have any questions about this, feel free to let me know. Again, we're going to go over basically what are the kind of things your teacher might ask you. So again, direction of opening, upwards. Another thing they might ask you is, what is the axis of symmetry? Wow, pretend that's a straight line, you guys. The axis of symmetry is -4. X equals -4, because that's exactly where this is symmetrical, right? So the X value of your vertex is the axis of symmetry. Your vertex in this case is -4, -1. And obviously your roots, like we solved earlier, are -5 and -3, or you can put the values like as points. But that's basically the gist of it, you guys. Overall, it's important to understand what's happening, which way it's opening, where are your roots, where is your vertex. Your vertex and your roots are really the most important part. So that's why next week we are going to cover how to solve for the vertex in a different way. This way is obviously cool too, but your teacher is going to expect you to know how to solve for vertex form and how to convert from quadratic form to vertex form. So this is basically the wrap for today. One last thing I want to say is the range before we go out. So the range in this case, we're only starting at -1 and moving up, right? So the range is y is greater than or equal to -1. Okay? Y. It really should look like this, but if you guys, we haven't learned that yet, so it's okay. Alrighty, guys? Thank you so much to all of you in the grade 10 class that stuck around and watched today. It's been a pleasure teaching you guys. And as you guys know, if you've been here other weeks, if you have questions that you want to submit before next week's lesson, because they might be harder to submit in the chat, you can email us at admin@scholarlyelite.com. If you have questions that you would like a one-on-one tutor to answer, we do have online tutoring. It's a very similar platform to this. It's a little bit more intense because you have like a virtual explanation and you're able to see the tutor and all of that fun stuff. But you are welcome to join us again next week at the same spot, same time, same place, and we can help you out with any questions that you might have, okay? So I wish you guys all the best. Stay safe out there, and we'll see you again next week, okay, guys? Thank you so much and have a good one. Talk to you soon. Bye. Oh, and thank you, Roman, for the kind words. That's really nice of you. Thank you for asking everyone to like this video. I do appreciate that. Alrighty, guys. Have a great day. We'll talk to you soon. Okay, guys? Thank you so much.